In the previous video, I took apart the HP Reverb G2 Omnicept Edition headset, this one here, to have a look at what's inside it and to see how it works and see if we could get this one to work, because it doesn't work. We weren't able to get it to go, but right at the end of the video I had an idea to take the housing from this and put it onto my other G2 that has ruined microphones, and that worked. So this is all going again now with good sound. The original housing is here, and there are the microphones in it, and I have no idea what happened to those, but presumably when I was pulling the guts out of it, the cables got yoinked and somehow broke it, even though they look completely fine and they're still connected up fine. But we've proven that the board's alright and the microphones do work when you hook up ones that do work. Today, well, after that last video, I had another idea. Why don't we try taking the board from this, which is all proven to be working, and attach it to this, the rest of this headset parts, which will allow us to power up the screens for the first time ever and see how they work. And if that does all work, then let's see if we can attach this board that does the eye tracking and other sensors onto this and get the eye tracking working on that. But there's a number of things. We need first to put the board on there and see, does the picture come up on this okay? If it does, then we've got to work out how to get this connected onto there, because we found the pinout of that connector, which goes from there to there, is different between these two headsets, and I don't know why. This one here provides 6 I/O lines and possibly only 1 power supply, whereas the one here that this board goes on provides what looks like at least 3 different power supplies and 1 USB port. So it might be quite hard to get this going if it does require a bunch of different power supplies. I don't really know why, because this should be able to get all this power supply stuff on here. Can't it just do all that from 1 voltage input? We'll try. We'll start by measuring what's on the pins of this. This is powered up right now, to see what the voltages are on different pins, to see what we have available to use as a starting point. The meters there, we'll just reference it to this ground and then go along these pins. That's some kind of I/O. 3.3 volts on the one that has the track going to it. 1.7 volts on that. 5 volts on that one. We do seem to have a decent amount of voltages available. Okay, we're going to look at what voltage is available on what pins and then try and draw a little chart to help work this out. Pin 1 is nothing, 2 is nothing, 3 and 4 are data, 5 and 6 are 3.3 volts. 5, 6, 7, there's nothing. I think that means it's ground. 7 is ground, 8, 9, 10, nothing. 11, 12 and 13 are 1.8 volts. 14 is ground again. 15, 16 is nothing. 17 and 18 are 5 volts. So now we have a chart of what voltages are where on what pins. So we do have 3 voltages available on this. That's more than I thought, because it looked like there was only 1 power supply track going. They must have made like capped wires on those other ones, so it doesn't really look like they go anywhere, but they do. So that's good. We probably have everything we need then. In that case, before we destroy this, we'll power this up again and measure the voltages on this one to see if it makes sense. Well, to see if it is the same voltages in the same positions, and then we'll proceed with swapping the boards over. Okay, so this can be shut down now. Oh, my computer is very angry about something. The mouse doesn't move smoothly. Anyway, so we're going to unplug that. I suppose it doesn't matter that it's not turned off. And plug it into the other one. and just check if those voltages are the same or not. That whole thing there is quite warm. I wonder if there's like, because this block thing that's in the other end of the cable near the computer end, it presumably has line drivers in it for driving the high-speed signals for DisplayPort and USB 3. So there's probably the receiver end inside here so that it's properly matched. So like they would train the links across the cable so that they match each end and gives a clean signal out to the headset. It's probably why that's warm. There'll be stuff in there. I don't have a dud cable to take apart, and I don't really want to destroy my good one to find out what's in there. Send me your dud cable so I can pull it apart. Okay, that got hooked up. Look, it's going to start. Well, it's going to probably get to where it got to before, which was dead. Because the USB is sad. See, the cameras, which I think is supposed to be there, have packed a sad. And the audio is gone because we cut the tracks. So there's not enough stuff for it to be detected as the normal headset anymore. But that doesn't matter because all we care about right now is measuring what the voltages are on those pins to see if it matches what that other interface has. So let's see. 3.3 volts. Covering the meter. That's the same. And then the top corner here was 1.8. Oh yeah, that is 1.8. I'm using the multimeter to prop up that thing so it doesn't fall over, but it means you can't see it. Will you take my word for it? Look at that, 1.8 volts. Where it said it was 1.8 there. And this last one, 5 volts. Oh, that's a bit low. Maybe that's what's wrong with this headset. Maybe we've solved the problem. The 5 volt regulator in this is either overloaded or ceased to function. Whoopsies. Ripped off the little clippies that hold that shield plate on by being rough. Anyway, I was wondering, maybe we just get a thermal camera out and see if there's something getting hot here. Fingers can tell anyway. Should we do that? The problem is it's over there. So if the 5 volt rail is 4.1 or whatever that said, that's a bit out of spec. And that's not really what we want. An out of spec 5 volt rail. Where does it even come from? Over here somewhere will be... Okay, it measures 5.3 there. It could just be because... Nope. See, that's the one that's got a tiny little switch in it. That little black thing there, which is a switch controlled by that line there. So I thought maybe there's a voltage drop across that, but no, that doesn't seem to be the case. Because on the input side of it, it still measures 4.1. I don't know what other stuff on this would be powered by 5 volts, so I don't know where to probe to find it. See, I tried that test point there. That's 3.3 volts on that. That test point up there, that says 5.3. So there's either multiple 5 volt regulators and one of them's sad, or this is supposed to be 4.1 in the first place, but I don't think so. That's not a normal voltage. It's a bit weird. I don't know, how can we find out where that comes from? The way to do it, which doesn't work so well when you've got tinted wires and things, is get a very fine conductive brush and join one side to there to your multimeter and the other side to the brush and brush across the board until you find continuity and narrow it down to where it goes. But in this case, there's so many internal tracks, all the wires are tinted so you can't make connection with them. There was no connection to the V bus on that sound IC, because that would have been where 5 volts would be, but instead that 3.2 volts on the sound chip, some kind of power supply business there that's not hooked up to, it's all non-fitted components. There's a power supply there, seems dead. Maybe that only switches on under some conditions. I'm blocking the view anyway. Let's just proceed with the original plan, which was to get the board out of that other headset and stick it on here and see if we can get it to start up. So we're going to undo all this stuff, get this board out, and get the board out of the other one, bring it over here, and try powering up this business with a different board, a known good board. There's a lot of delicate things to undo. These cameras are the worst ones because the ribbon cable is folded over the connector, so you can barely get in there to get it connected. There might be more power supply regulator business on the bottom. Maybe we can find out where that net went to. 5-volt supply. Yeah, look at all that business. That's probably all the power supplies that run this stuff. So that thing there, little tiny weeny black thing there, which I think is an on-off switch type doofy, and then the input side of that's here, and that must connect somewhere inside the board. We'd have to power it up in this way. We might be able to meter it out and check if those things there look like different power supplies. It's because they got inductors there, little tiny surface mount inductor, some kind of controller, capacitors, that's probably a little FET. Similarly here, some kind of thingy, an inductor, another thing with an inductor, another one there. So they're all independent little switch mode power supplies. I'd say that stuff there is probably Class D amplifiers for the audio, since the connectors going to the speakers are right there. 2 amplifiers. Alright, so this is the ruined board, the not working one. Now we try and extract carefully a good board from this to put in its place. So undo all of the connections without ruining them. The aerial for the controllers, yeah, that's a little like Bluetoothy type thing for the controllers. And then to undo these front camera connectors, you have to first remove this little plate that is attached on top of them. Now there's a whole bunch of screws to undo to release this board. Okay, another one up there. Oh, is this not going to come out because it's being blocked by the housing? It's annoying. There's a screw we can't get to easily because of the housing. Bend it out of the way. Oh, that's right. There's tape. Yeah, where the connector comes in, there's tape across the top, so that's going to stop this from wanting to come out. Oh, maybe we're going to have to pull it out of the housing first to peel that tape off. There's screws here that have to be undone. And then the IPD adjustment knob thing has to come out again, which is getting very fragile. I've already broken that one, so it won't stay in anymore. The little clip thing underneath that holds it in broke off. This wasn't really clipped in properly, so it comes out pretty easily. Which is good. So that's freed from there. Now this tape can be peeled off. Now, oh, we didn't undo that. Now we need to get that off as well. Just get that whole thing out of the way. That's the good one. Remember, that's the good one. It has microphones that still work on it. Now this has to be peeled off, which is the presence sensor thing, and then released. Yeah, those would have ripped that off. Now we should be able to get the board out. Good. So that's the regular G2. Let's Put that out of the way. Now this is the Omnicept one with the eye tracking stuff. Just going to install this board on there. Key thing is to get all those ribbon cables up onto the top side without munting them too much. And get that IPD thing in the right place. Look at that, it just goes perfectly. So I must have set the same IPD on both of them. So that little trimmer thing, variable resistor, whatever you call it, is in the right place. Just get some screws in just to hold this down so that we can work on it without it flopping about. Okay, then we've got to connect up a whole bunch of cables. Now these difficult ones. For the cameras on the front. Is it going in? How would you know? Well, it's stopped moving around or flapping about, so it must be attached. It's sad they had to do it like that. Probably people working on this project that were unhappy about that. Because of how tricky that is to do. It's really difficult for reliable manufacturing. And then they have to implement that clip thing to hold it down. It's such a dodgy, delicate connector. Probably it's a pre-made camera module, so they're just stuck with it. See, even the side cameras have the same thing. They've got the same connector, and they've had to implement this thing and put this bracket on it to hold it down and stop it from coming off. I think this is ready to turn on. Should we turn it on? Let's see if it does anything. We'll bring back this stuff so we can see what happens. I'm going to be wearing out my cable, nice cable and connectors by plugging them in so many times. Oh, look, it came up. The screens are dark though. Yeah. So it thinks it's working, but there's nothing on the screens. That's weird. Do you think they're different and not compatible? Yeah, there's nothing going on there. Normally they'd be lit up. That's weird. So I guess the plan failed because it doesn't work with these panels. Yeah, we found out last time that it says it encountered a critical error. That's weird. Did we bend this too much? No, it looks like it. Screens don't come out, unfortunately, as we tried that last time, unscrewing this stuff, and it seems like the panels are like glued into the back, which is pretty sad. I was wondering maybe if we just try replugging the display cable in case it's become sad about something. Maybe we should swap the USBs over as well so that it can like have a new go at establishing a connection just in case something upset it. And it seems to have locked up now, doesn't it? It's got stuck. Try restarting it. Yeah, it's doing that thing where it won't recover unless you reboot the computer, I think. It can be quite finicky, especially if you keep unplugging and plugging stuff in like we've been doing. Yeah, we're gonna have to try rebooting the computer because it's not gonna do it at the moment. We used to have this problem that it would go like that after a while, and the only solution was to restart the computer and then everything would be good again for a while. Don't know why it was like that. But so far it looks like you can't just swap the boards over. Maybe the screens are different between this version and the other version. That's a shame. Had so much promise and hope. Let's see if it will cooperate now or not. Yeah. It's back to going. Sort of, except it's not detecting the presence sensor for some reason. Oh, I didn't actually do up that cable. I guess that might be why. No. Well, regardless of that, the screens are not lit up. So it's it's unhappy about something. Tracking fine, unless it's just too much light getting in so it can't do the detection properly. I don't know. What a shame, because at least that thing that's on the screen there should be visible in the headset, but it's completely dark. There's nothing going on at all in the lens. So I guess that's not going to work. For some reason there's a difference between these boards and it won't drive those screens. These cables here, I think it would at least turn on the backlight and you'd see a little bit of a glow in there. That nothing, maybe, yeah, the pinout could be different. So it's, you just can't tell because it's so, all the tracks are inside the board, so you can't really see any of the connections. The PCB layout looks the same. You can see there's a few tracks coming off that connector, and it's the same thing on there. You see, there's this one here, the Omnicept board. It says Rev F there after the part number, whereas this one here, it's just got nothing after the part number. I wonder if this is a very early one, but it's not an early one because this is from a G2 version 2. Better ones where they fixed the problem with the cable that allows it to work on AMD motherboards, and because it's come with the removable extra piece in here so you can get your eyes super close to the lens if you like them nice and greasy from your eyelids banging into them. Increases the field of view, but when I tried it, it was just made it all blurry because it was just too close. So I don't know, maybe what caused this board to burn out is that there's something wrong with these displays, or one of the displays. Should we try plugging it in with just one or the other connected in case it is one of the displays that's upsetting it? Might as well, since we're here. This thing's gonna get all grumpy again because I keep plugging it in and unplugging it. Now it's saying check display cable, so it's already became grumpy. Well, can it tell that one of the panels is not connected? That's possible, isn't it? Maybe it can. Oh no. Oh, I think this connection's gone bad. That's sad. Yeah, I think this plug might be wearing out for me unplugging it so many times. Anyway, that panel's not connected. This one is. There's still no light in there at all, so it's not doing anything. So we'll try the other one, and then we'll just put it back to how it was and see if it still works, and then that'll be us, I think, because we've fiddled around with this enough now. Yeah, we'll reconnect this one just to check what's going on. Yeah, maybe we've ruined it. Oh, the light is open. The light is on. Oh, look, here it goes. Maybe the cable was dodgy. It does feel weird and squidgy around these parts that it would be moving. And yeah, this cable that I'm using here is the one that came with the dead Omnicept one. But I did prove that proving the cable works. But yeah, the other side is still dead. So it's not going to work with this board and those panels for some reason. Either those panels are both dead or they're not compatible. I don't think we can work out which one of those situations we have here. Don't know, should we try connecting that to the other headset to see what it does? Yeah, I've already ruined this one by cutting through those tracks to the controller. But I don't want this to break the panels in here that we know work. So I'm not sure if that's a good thing to try. So we might not do that. We'll just put this board back onto there, which is where it worked before, and see if it still works. Hopefully you haven't ruined two things now. Otherwise we've gained nothing and lost more. Well, at least we got a fun video out of it. Sort of. Not really. We worked out the voltages of that thing, but it's totally worthless. It's just really sad that the cameras for the eye tracking go inside the lens. If they were if it was contained in this ring, then it would be feasible to move the eye tracking to somewhere else, like bring it into this one. But maybe there is still a way. If we can work out how to peel the panels off the back of these things, well, now that we know they're ruined, we can probably peel them a lot harder, can't we? And swap the whole lens assembly with these ones that work, then we can bring the eye tracking to it. Maybe panels are either dead or they are not compatible. It's probably more likely that they're not compatible. It's unlikely that they've both died unless whatever killed this board killed the panels in the same process in the same time, which is possible. It's possible that a regulator went crazy and overvoltaged it and burned it out, maybe, and now it's just sitting at 4.1 volts, all sad and lonely. Okay, so we put this back. At least we won't have to take this off again if we do decide to change all this panel lens business off, because that can be done without taking the board off. That lifts up a bit, I think, because that there screws onto heat sinks. That's got that thermal pad under it, I hope. Or there's something else under there that's not supposed to be under there. Oh, I see. It is. It's that. The IPD thing's munched out of the way. Oopsies. There you go. Now the board's sitting flat. Oops. We'll just put back all the screws. We have high hopes for this being awesome. Alright. I think that's all hooked up again. Let's just test this again. Again. See what happens now. Should light up this time. Better light up this time. The ultraviolet just seems to work. Yes, look at that. There is light in there. I can see it when I shove my eyes into that hole. See? There you go. Look, the Cliff House has loaded. The Cliff House. Go to the Cliff House. The house on a cliff, see? You can see the sea out there. Oh, the exciting possibilities of Windows Mixed Reality that no one uses. They just go straight into Steam VR and get on with their life. Oh well. Anyway, we proved it works again. So that means we're giving up on the panels that are in here. So maybe what we should do is try and take them off and have a look at them this time. Yeah, so this is still a useful piece because I could use it to repair my other one, the other Omnicept, where that thing for the head strap snapped off of it. These rods that I didn't put back properly. The tape. There you go. So last time we abused this thing significantly by attempting to remove the panel and not succeeding. And then I put it all back together. That one didn't get touched, so even if I had ruined this panel, we still should have seen that one there light up. I doubt they'd join the backlights in series or something. See? That's the back of the panel. It's got some kind of reflected thing on it too. It must be double-sided reflected to stop the backlight light from leaking out the back. So that's the backlight there. Yeah, we're just destroying this. It's too late for any of that. Well, we can't get it to work, so too bad. Oops, it just tore the backlight cable trying to unplug it. What I want to know is how do you get this out without destroying it? Because if we want to reuse this eye tracking lens thingy in that other headset to follow this dream of giving it eye tracking, how can you get out the good panels without destroying them to put them into this? Because if you just yoink on that cable like that, it's just going to rip it off. It's stuck down so hard. Yeah, that cracked the glass and destroyed it. See? So that's ruined now. Because half of it's come up. At least we can see there's some kind of sticky stuff there that's holding it down. So maybe what you'd have to do is heat it up enough for that glue. Oh, look, the glass is all broken in there. I don't think it's feasible, is it? I don't want to destroy that one there by trying to remove the panels and then breaking them in the process. If we can get that off, we'll at least take a look under there. But now, anything I touch now is going to cause glass to go flying everywhere. Because it's completely sealed, there's no other way of getting in there to poke it out. So I couldn't get the lens off because that was like sealed on as well. I tried picking at the lens without any success. Oh, look at that. There is in there, it's another, see that? There's a sheet of glass in there on an angle. So that's how the eye tracking works. So the image of your eye is reflected off that glass there into the camera. Which you can see that tiny little white dot there. When the light catches it is the eye tracking camera. So that's why it's on an angle there. So that angle lines up with the angle of that glass in there. So the image of your eye gets reflected off that glass into the camera. That's cunning. That's a good way of doing it because it means your eye gets a really good undistorted view, or the camera gets a good undistorted view of your eye, not like those homemade ones, which I have hiding here, where it's a super wide angle camera that you put around the edge of the lens, and then that has to look at your eyeball, which is sitting about there, which is really hard to get a good view of it from that angle, which is probably why that homemade eye tracking doesn't work very well. Yeah, there's a mess on there that's going to be too hard to get off. Yes, I think it's not practical to transfer the panels from that other headset onto this. It's just not going to work because it won't be possible to get them off without at least destroying them slightly. They might end up with dead lines or something at best. Glue. What a shame they glued it in. They could have just used some foam and then this clip bit at the back would hold it in perfectly. Wonder what the idea of gluing it down was. Alright, there you go. I think that's it. That's the answer. That one doesn't work. This one looks like it does still work. So that's good I think. Good that it still works. Nothing to see on it at the moment because it's at an angle. So we're going to put that back into this housing and then that will restore a working G2 at least, but without eye tracking, and it looks like it's completely impractical to put it on there because we couldn't get those panels to work and it's not possible to swap the panels without destroying them. That's pretty sad, but I don't think we can do much about that. But wait, there's more. I put back together the normal G2 headset and confirmed everything on that's working fine. The microphones still work, the picture's still good. So that's good. It wasn't all lost. We got back the thing that worked in the first place and didn't ruin it in the process, so that's pretty nice. I thought, why don't we do another thing and take apart the controller? This is the G2 controllers and it has white LEDs that shine out around where these little dots are, and the cameras on the headset track those. Well, look at the dots to see where it is. So we might as well turn this on just for fun. Because I was using these for quite a while before I got the much better and highly recommended index controllers, I got these batteries for them because it said that these need to have proper 1.5 volt batteries, otherwise they won't last very long. So I got these USB-C rechargeable 1.5 volt batteries. So they got a little tiny lithium cell in them, and then that gets boosted up or bucked down probably to 1.5 volts. So they actually run the controller for a pretty long length of time, 20 hours or so of use in theory. I guess these are flat. I don't know, because I don't use these controllers much anymore, don't really hardly ever use them. We get just charge these up for a little while. Yeah, that's annoying, isn't it? So we're going to take this apart. Let's just get the screws out while we're waiting for these batteries to do something. Let's just have a look at what stuff's in a controller. Guess it will be some little microcontroller thing, some radio receiver thing, and not a lot else. A vibrating motor for feedback, haptic feedback. You see there's a little button there, the pairing button to pair it, I guess. Never had to do that because I've never exchanged controllers around. Always just used the one that came with the headset ones, and they just came paired and just worked. That's really weird, isn't it? Let's check the battery. Yep, completely dead. Okay, great. This one works. The other one does not. I don't know if it's died or it's just... yeah, I bought a whole bunch of them. One of them didn't work from the start. And maybe another one's died, or it's just decided to go completely flat. I don't know. They were really cheap on AliExpress, so there you go. Bought a whole bunch of different ones, but I think they're just the same thing with different capacity battery, like lithium batteries inside them. There we go. Look at that. You can see the thingies all lit up nicely. So the headset cameras look at that, and then from seeing that it works out where it is. Good. So that battery's just dead. We might as well put the other red one on to charge as well, because I'm pretty sure they were used together, so they'll probably be similar levels of flatness. Alright, let's take a look inside this thing. Not really sure what comes off. Oh yeah, I think that is a screw. It's just covered up by a tiny little sticker, like a void indicator thing. Maybe? Yes, it was. Interesting. So they had a little sticker over it to make it look like there was no screw in the hole. Like it was just a plastic molding. Oh, look at that. All the good things are happening. So that button there on the side has got a magnet. It's a magnet there. And that, presumably that thing, SOT23 package, is an analog hall sensor. And there's a Frisco Logic, I think. Is that what that little logo is? Freescale? Is it Freescale? I don't know. Some kind of microcontroller. There's a little haptics vibrating motor. You might have heard it do a little beep when the power was turned on. And then there's a cable, a little ribbon cable there. And this other cable, which, oh yeah, it's got a plug. A few cores there, that's probably going to the LEDs. Look at that, then there's 2 layers of PCB in there. I guess one is at the right height for this joystick, and the other one's got the buttons on it. These aren't capacitive sensitive buttons like these ones here are. So on this one, just bringing your finger above any of these buttons is detected as an input that is independent of pressing the button. So, and there's capacitive sensors in that part there, so it can independently sense your 3 fingers. This is a touchpad you can use for scrolling, joystick, and that has touch sensitive. All these things are touch sensitive, even the power button apparently. And this one here, that has, you can probably see it, it emits infrared light. This is probably going to upset my computer, so it's going to start doing stuff. In theory, infrared light comes out of that and it looks for the reflection back from your finger. See any evidence of that occurring, but supposedly that's what happens. This has a very granular range. It will measure your finger as it does that, as well as that being an analog input of how much you're squeezing that lever. Quite good. It uses the lighthouse tracking. There are sensors along there that you can see for detecting the beams that come off the lighthouses. It's very good because you don't have to hold on to anything. This just sits comfortably in your hand and you can push the buttons, and yeah, good. Nothing else is as good as that for VR use. Okay, what happens next in this? It looks like that piece needs to come out because there are screws obscured by that. It don't really matter if this gets destroyed in the process because, well, the headset that it belongs to is already ruined and I have several other ones, so too bad. Doesn't matter. Maybe there is. Oh, there's something in there, look at that. That one there is also a Hall effect. I don't remember these being proportional controls, so maybe it could be a digital Hall sensor. Hard to say, hard to know. Looks like that comes out. Guessing this would just be a flexible PCB with some surface mount white LEDs on it. Wrapped around here, snapped together, some kind of light guide. Yes, look at that, there's the other end of that cable. And, oh, okay, so there's inner LEDs, and there's these, look, there's a white flexible board. Each one of those is taped down. Wow, it's expensive to manufacture. And there's a bunch of screws in here. Okay. Oh, look at that. It's a white flexible PCB with little dots. And it's all, oopsies, it's ripped now. Okay. Just thinking it might all just peel off in one go. It doesn't. No, it's not going to unless, oopsies, I snapped off the LED from that one. Yeah, there's LED, there's resistors, and they must be in like groups of a certain number in series, probably so that it adds up to close to, no, it wouldn't be 3 volts, maybe there's a boost converter in there, because each white LED will be around 3 volts on it. Will it? I don't know, I can't remember what LEDs do. Maybe it's 2 point something. Oops, it ripped off again. Oh, is that the connector? That was the connector, wasn't it? That just got ripped off. Oh, they glued the wire into it. The connector, the plug got glued into the connector. Okay, so it just ripped the connector off. Oh, that's lovely. It looks like the white stuff, the light guide, is a whole injected mold into there, see? Coming up to the edge, forming screws. So it's a 2-shot injection molded part. Pretty interesting. And then that looks like it's part of this. This is part of that. That's a really complicated part to make. But this cover, you see, is clipped in there. I wonder how that comes out. If it comes out from this end. Does that do anything? No. I'm going to cut it off. Cut off the clips. Is that coming out? Label with a whole bunch of stuff on it. Don't really know how that was attached. Don't know what to do to undo this thing. It's like no obvious way that it's connected. Oh, there's tape involved. You can hear that hissing of tape peeling off. Okay. Aha, look at that. So that piece there is taped down, and that covers a whole bunch of screws down there. No wonder. It's always the go, isn't it? Tape something over the screws to make them hard to find, hard to get to. One more here. Okay. Magnets in there. There's the cable that goes up to the LEDs. The little joystick. Oh, that's interesting. When you push it further, it gets stuck in those positions. I wonder if that's a feature of the joystick. That's not used here because the shape of this housing stops it from being pushed that far. Interesting. Interested to know if those hall sensors are they analog? I suppose we could power it up again and measure the output from them. Thumb stick. Oops, one more screw. Oh, look at that, there's another little processor thing. Some kind of IC. Super tiny. Oh, there's also an aerial connector there. But I don't think there was any aerial connected. Yeah, that was an option. In case their PCB aerial didn't work. Which is there. It's probably got... We've got to get that microscope camera back in here, haven't we? Alright, so that thing there. So this thing is the wireless transmitter thing. Is that a connector there? Looks like one. And then it goes up there to PCB trace antenna. You can see that it's connected through a little inductor. The connector, and that comes out of this chip. And the chip's got a bunch of other stuff coming off of it. Is there anything on the other side? No, but that's where the connector is. It's been taped over. Now, on the back side of the thumbstick board is the other little hall sensor thing. Possibly through wave soldered. Though probably not, because there's that which is surface mount on it. Maybe that's selective soldered. Probably is selective soldered because you can see the ring where the little volcano of solder would have come up and gone into those different positions. Carefully avoiding the stuff which has been surface mount pick and placed on. Pretty good manufacturing. Bunch of surface mount stuff on this side of the board as well. I guess it's just filtering and debouncing. Looks like it, doesn't it? Amazing, isn't it? How much stuff's involved in just a controller. It would be so much easier if the controllers were not wireless. See this little oscillator module on the back there for that. Now if we get the main board out, yeah, the battery spring's a part of that. So there we got the haptics vibrating motor thing. Looks like an 8 MHz oscillator. 0 ohm resistor or fuse of sort. Main processor thing. And the other hall device. Look at that, it's a 494FX. Wonder what that is. Don't know if we'll be able to find that. Comes up with nothing. Alright. What's on the other side of the board? Bunch of transistory looking things. Kind of weird and wide though, aren't they, for slot 23? Another little thingy there. TH66. And some kind of programming or debugging test interface. And then another little device down there. Might be something to do with power supplies. So there's 0 ohm resistor going into it. Maybe there's a little boost converter for the LEDs maybe. Very good. Lots of stuff doing this. So there you go. Surely that then concludes our look into the HP Reverb G2 Omnicept and also HP Reverb G2 repair attempts, desperate attempts to try and get something, what an annoying thing that was, get something sorted out and working. Anyway, hopefully that was enjoyable. Let me know and stay tuned for next time when we will take a look at some other thing. Hopefully as exciting as this. See you later.